Martinez, and this is my Fluids Project 1 for Dr. Ozbay, summer 2026. So I already did this, but for the sake of this video, we're going to be redoing it. So first thing first, my part was the Poiseuille flow, so I'm going to be showing that. I go into Analysis Systems, Fluid Flow Fluent, which is the tool we want to use, drag and drop. So once this is open, the default is 2D. I want to change that. Default is 3D. I want to change that to 2D. Once that's good, we could start actually designing our system. I like using Design Modeler. So once the Design Modeler is open, I could go ahead, look at my axes, 0 on the z-axis. I want to start sketching. I did a rectangle starting on the origin. To add dimensions, you would go right here. I like this tool general. You could do vertical and horizontal. The general one seems to be catching stuff pretty well. It's kind of like a smart dimension in SolidWorks. So I click it, I change it. Oh, before I do that, actually, units, millimeter. So I did the height 10 millimeters, and then the length. Oh no, it's a little weird. Okay. And the length, I made it as 1500 millimeters, which is part of the, well, not these dimensions exactly, but the ratio is part of the requirements for the project. So now that the rectangle is done, we want to create a surface from this. To do that, concept, surfaces from sketches, change this to box select so I could easily select it all. Apply and generate. Yes, apply and generate, and that should generate our surface. And now that's generated, we go back to the workbench, green check mark, perfect. So now we're gonna go on to meshing, which is a little more in-depth and complicated. I'll double click the meshing, let it open up. Once it is open, I want to change all these names so it's easier to kind of see what's going on later on. Right click, insert, name selection. Oh wait, no, insert name selection, then you click the geometry you want. Apply. Wait, this is, wait, let me go back. Okay, yeah, here it is. That's the one I was looking for. Upper wall. Then you gotta click and then right click, that's why. Lower wall. Inlet. And outlet. So now we have the 4 name selections. You can see it highlights them all when you click it, which will help us a lot later on. Now we can start actually meshing. I want to click on the mesh, or right click on it, insert sizing. We're going to go with the top and bottom first. So geometry, I'm going to control click the top and bottom, apply. Set of element size, I want to change it to number of divisions. Number of divisions, I think I did 2500. Yeah, I think I did 2500. Capture curvature, no. behavior hard. Boom. Now you want to do the same thing again, but for the sides. So sizing, geometry would be the side and it's giving me a little problems, but we'll get through it. We'll get through it. I am not very familiar with the UI. There. Now we're gonna control click. The other one. There, apply. Is that two? Perfect. Now we're gonna do the same thing. Instead of element size, we go number of divisions. This, since it's the height, you don't need as many divisions. So you don't need the 2500. I went with 50. I think I went with 50. I might have gone with 100. But yes, doesn't have to be as much. Capture curvature, no. And behavior as hard. Now we're gonna go to insert face meshing, click our surface, apply, and all the defaults here should be fine. So now that that's done, we can actually generate our mesh. This might take a while, so I'll skip through it. So once it's done generating, you should be able to actually look at the mesh by clicking here. Yes, here's our mesh. Seems pretty standard. Should work for our purposes. Now we would go back to, once you verify the mesh is not abnormal, back to the workbench and get on to the setup. Actually, before the setup, let's update this so that the green check mark pops up. Perfect. Right click setup, properties. Instead of single, we're going double. Just more accurate, basically. And we double click on the setup. Let that load. Oh, never mind, I lied. Double click on solution. So now once this is open, first thing to do is to change the flow. And to do that, we would, where is it, models? Oh, it's still loading. Yes, I hear you. Models, viscous, edit. We want laminar for this project. Now we could go to residuals. Where's results? Where's the residuals? Results, plots, residuals. Let's change all of these to two, 1e -6. Okay. Now let's change up our fluid, materials, fluid, air. Double click. I'm gonna change this to 1, and then the viscosity to 1 also, 1e to the -5, just for it to be a little more uniform, I guess. So now we can finally go to stuff specific to Poiseuille flow, boundary conditions. Start with the inlet, change the velocity. So I chose 0, I think 0.04, very low, so that the flow would stay laminar for a long time, or would become laminar very quickly. as well as lowering the Reynolds number. Apply. Then we're going to do the same thing for the outlet pressure. There it is, outlet pressure. We're going to put prevent reverse flow, so we don't have any backflow. And then apply, close. And now let's check our walls, make sure they're stationary and also non-slip, which is part of the Poiseuille requirements. Stationary, no slip. Good. Other wall should be the same. I'm pretty sure those are the default values, but just make sure. Yes. So now let's go ahead and initialize. Just double click, initialize. Let me save this work before I do that. So it wouldn't give me that pop-up. Project one fluids vid. Save. Once that loads, should be able to initialize without that pop-up. Initialize. Ooh, I think I might have crashed it. Let's let it think for a little bit. Well, I think it worked. Let's see if it lets us run the calculation. This number of iterations. Let's change it to, I think I originally changed it to 100 or no, I think it was 150. And then it might crash again. Yeah, my computer's having a lot of issues right now. Very interesting. Finally stopped crashing. Now it's running the 150 iterations. Let's let it run. I'll unpause the stream once it finishes. Well, the calculation is complete now. Amazing. We could go back to the workbench. No. Close these two to save a little bit of RAM in my computer since it's been crashing a lot. That close. It didn't close, but we'll just live with it. Now let's open up the results. This is open. First thing I'm gonna do is add some reference lines. To add a mid line. So the X would be, since it's 750, 10. There should be a midline. It's not a midline, interesting. Oh, maybe. There it was. I don't know why it took me so long, but there is the midline. Now let's also add another end line. So we want it to be right next to the, it can't be on the outlet, but it could be right next, which is what we're doing right here. Yeah, seems to be good. On top of that, we're gonna do a not inlet line, but kind of developing flow. That's what we'll call it. Developing flow. So that later in our chart, we can see the difference between the velocity vectors here, and like once it's developing and when it's fully developed. So let's just put that real front 0. Say 0.5. That seems good. Oh, I forgot to change samples to 100. Let's do that for all three. No. 100. Now we can start to develop the contours. So let's insert a contour. Let's go symmetry 1. Where's the velocity? Velocity U. Range global, number of contours. Let's just add a 0. And then apply. See if it gets what we want. Now we have our contour, which looks pretty good. Now we want to make our chart, so we go here, insert chart. Let's change the title for velocity profile for case 1. Data series. Start with our midline. End line. And developing flow. Let me rename those actually. Midline. End line. And developing flow. Then let's go X. Velocity U. And then Y to Y. And now we have our velocity profile. So as we can see, all three of them seem to be overlapping, which means our developing flow line was too early, basically. So let's see if we can fix that. Let's go back to 3D viewer. Let's make this more in the beginning. Because as the flow passes through inlet and outlet, you know, it starts undeveloped, then develops. Our line was too far developed, so it was all already developed. So okay, still a little. Let's see, 0, 0, 1, 0, 0, 1. I want to get a full. Yes, this is what I'm looking for. This is undeveloped, and we can see that by the midline and end line, they're both overlapping, so it's already fully developed by the midline, so the end line is obviously developed too. And yeah, so this is finished chart. Let's also add some velocity vectors to, yeah, let's add some velocity vectors. Let's go midline. Arrow symbol size 0.01. Now we have our velocity vectors, which should be similar to how like our chart looks like. And it is midline, the midline's here. Yeah, and with that data, we could finish the project, well, at least the first part of the project.